today's lesson is about cats in space. I wish. It actually really is about our super awesome sun. The SOHO is a space telescope that has had a clear view of the sun since 1995, so a lot of the images that we have of the sun have been taken using the SOHO. In terms of the nature of the sun, it is considered a medium mass star, and it's made predominantly of hydrogen, helium, and a little bit of other elements like carbon, oxygen, and iron. The sun emits radiation, so the different types of radiation it emits are visible light and UV radiation. It has layers, kind of like how ogres are like onions and ogres have layers, onions have layers. They both have layers, as does parfait. Everything good has layers, so naturally the sun is a good thing. These are the 6 layers of the sun, and you will have to know what goes on in each of the layers of the sun. So this here is an organizer chart that you should copy out and use pages 308 to 309 from the textbook, the online textbook, to help you figure that out. Now we're going to go through some surface features of the sun, the first of which are sunspots. These are temporary spots on the sun that are lower in temperature than the surrounding area. So they're about 4,000 degrees Celsius as opposed to about 6,000 degrees Celsius. They indicate regions where the magnetic field is so strong that it slows down convection. If you recall, convection would be the rising of hot gas followed by its sinking as it cools. One really interesting thing about the sun is that it experiences tornadoes, more extreme than those that occur on Earth, and it can take different forms. The first of which is a solar flare. Solar flares are short-lived bursts of gas, so a massive explosion that occurs on the surface of the sun because there's a release of magnetic energy which flings hot plasma out into space. Then you've got solar prominences. These are streams or particles that extend from the photosphere into the corona, and it's frequently in a curved shape that forms a complete loop, and that's something that can last for hours. If you're looking at the image there, there's a picture of the Earth that's shown for comparison in terms of size, so then you get an idea of how large these solar prominences are. A CME is a coronal mass ejection. It is a powerful kind of flare that reaches the Earth's magnetic field 3 days later, and that can cause really vivid, beautiful auroras, and consequently it can damage orbiting satellites. If you're looking at these two images, do you know which is a flare or a prominence? If you chose A as a solar prominence and B as a solar flare, then you are correct. One thing you might wonder is, what protects the Earth from the intense heat and radiation from the sun? You know that the sun is very powerful and it emits a lot of heat, and we can even feel the sun's warmth on our skin when we're outside during the day, but what is it that prevents the Earth from getting too hot? Yes, there definitely is the ozone layer that protects us, but there's something more than just the ozone layer. There's something called the Earth's magnetic field. So we have EMF protection. The Earth's magnetic field deflects most of the solar wind and actually prevents the ozone layer from being stripped away. Do you know how else the sun affects the Earth? First of which would be the solar wind. So there's this constant flow of particles streaming out from the sun's surface in all directions. The second would be auroras. So you've got the aurora borealis, which are your northern lights, and then your aurora australis, which are your southern lights. These are produced when charged particles of solar wind collides with atoms and molecules in the Earth's atmosphere. An aurora means glow. This forms as particles from the solar wind are trapped by the Earth's magnetic field and are swept towards the north and south poles. So just a reminder, don't forget to copy out this chart and fill in what occurs at each of the layers of the sun, found on pages 308 to 309 in the online textbook.